Alright, so this is 3.9. We're multiplying and dividing rational expressions. If you had to take a guess what 310 is, what do you think the next section is going to be? We're doing multiplying and dividing. What do you think is next?
Adding and subtracting.
Adding and subtracting. So today, we're going to cover multiplying and dividing, and we're going to cover adding and subtracting of rational expressions. This is an example of a rational expression. Notice there's no equal sign. It's an expression rather than an equation, because equation means equals. There is no equal sign. All we're doing is simplifying.
Which one's harder, this one or the adding and subtracting?
Depends. I mean, it kind of depends on your abilities. I think this one's easier. Okay? Some of you can't add, subtract fractions without a calculator, and that makes it more difficult. Having said that, if I've got 1/2 times 3/4, let's go back and remember middle school or even elementary math. Multiplying fractions, what do you do on the top and what do you do on the bottom? You multiply. You multiply across the top and get 3, right? And what would you get on the bottom? 2 times 4 is 8. So 1/2 times 3/4 is 8. Okay? Now let's go back to this. The name of the game is just like what we did last week. Factor, factor, factor. That involves GCF. That involves difference of perfect squares. That involves trinomials. If you're a good factorer, then this is going to be a piece of cake. If you struggle at factoring, then you're going to have trouble with this section. Okay? I'm going to review you as much as I can over factoring, but you're going to have to go back and watch the videos or come to extra help if you're poor at factoring. Okay? Alright, so here we go. X squared plus x minus 6. Does that factor? Well, let's see. X plus and x minus. What are the factors of 6 that have a difference of positive x? It needs to be positive 3 and negative 2. Okay, so notice I cancel that out. Once I factor that into those two binomials, then I need to cancel out what was there. Okay, it's going to pay you dividends if you're neat and if you're organized. Okay, you're going to come out ahead. You're going to get problems more right if you're organized. Okay? How about 10x squared minus 20x? When you see a binomial, you're thinking two things. What are they? Binomial. Okay, what are you thinking? You're thinking GCF, right? Does it have a GCF? Or is it an x squared minus 4 type of problem, the difference of perfect squares? Is this the difference of perfect squares? No, it's not. 10 and 20 aren't a perfect square. So what's the only other choice? GCF, GCF, GCF. What is the GCF of 10x squared minus 20x? 10x. What if I just pull a 10 out? Am I going to get the problem right? No, you've got to pull out the GCF. If I pull out a 10x, what's left? X minus 2. X minus 2. I pull a 10 out of 20, I get x minus 2. Okay, notice how I canceled out what was there. Okay, what do you think I need to do on the other side?
Do the same thing.
Do the same thing. Factor, factor. Hold on, I can cancel or pull out a GCF of what? 5x, right? I pull out a 5x and what's left?
X plus 3.
X plus 3. Okay, I pulled out a 5x because it was a GCF and I'm left with x plus 3. David?
On the first problem, would you cancel out the x minus 2?
Not yet. Not yet. We're getting there. Your first rule is to factor everything you can factor. What does x squared minus 2x minus 15 factor into? X minus 5 and x plus 3. I'm not spending a whole lot of time talking about factoring and checking and the whole 9 yards because you're supposed to be good factorers. Okay? At this point. Notice how everything's canceled out and all I have now is the factored form of all 4 things. Now cancel. And this is how you don't just start randomly canceling. Start in the upper left-hand corner and work your way across trying to cancel. If I've got x plus 3, does that cancel with an x plus 3? Well, I look down here, I see an x plus 3 and an x plus 3, and those can cancel. One's on the top, one's on the bottom, they cancel out. They're gone. Okay? Then immediately I go to x minus 2. Don't skip around. Be organized. X minus 2. Then I look. Do I see an x minus 2? Is it okay to cancel top and bottom? Yes. Cancel, cancel. And they go away. Okay? Are we done? No, we got to keep looking. We come over here to this 5x. We're moving our way across. We got 5x and 10x. Does anything cancel there?
Yes.
Yeah, the x's just go away, right? But then I've got 5 and 10. I know that cancels into 2, but where does the 2 go? Does it go on the top or the bottom?
The bottom.
Better go on the bottom. The bigger number's on the bottom. So it needs to go on the bottom. Some people mess that up. Now watch. I cancel out the 5 and the 10 and I put a 2 here and circle it. Why would I do that?
To remember.
So to remember so that you don't leave it out of your answer. Okay? Don't highlight it, circle it, star it, whatever you've got to do so that you don't forget it. Okay? Keep coming across on the top. I got x plus 3. Does that cancel with any x plus 3s?
No.
It would be good at this point if you circled this, I circled the 2, and I circled the x minus 5. That way I don't leave anything out of my answer. Okay? I know. On the top, the only thing I had left was that x plus 3. What about the bottom? What's the only thing I have left on the bottom? A 2 and a what?
X minus 5.
And an x minus 5. That is your simplified answer. Next question. Are they going to ask you excluded values on these problems? They could, but probably not. Okay? They could, but probably not. Was that your question, Logan?
No, I was going to ask, like, basically what we're doing is factoring and then canceling.
Factoring and canceling. Factoring meaning all of these things, all of your tools in order to factor, you're factoring and then canceling. Okay? Question. Only other thing to add on that, Logan, was what if there was a 3 here and say a 2 here? We factored, we canceled, we got a 3 here and a 2 here. What are you going to have to do with the 3 and the 2? Multiply. So this, I don't want you to leave out. Our operation that we're doing is multiplication. What are we going to do in a second?
Divide.
Divide. And how is that different? What do we do when we divide?
Flip it.
Flip the second fraction and then what? Keep it, change it, flip it, and then multiply. We're going to do an example in just a second. Yeah.
What if you can't factor one of the expressions? You'll do the same thing?
You would try, you do your best to factor, and most are going to be able to factor, and then you cancel what you can. If it doesn't factor, it doesn't factor. Don't force it into factoring if it doesn't factor. David? Savannah, please be quiet. Please be quiet. David?
You know how you canceled out the top left and the bottom right?
Mm-hmm.
If I say cancel the bottom right and the top right, would that be right still?
If you could cancel here and here, that would be fine. Here and here, that would be fine. The only thing you can't cancel is a factor here and a factor here. You can't cancel across the top or across the bottom. Okay? Great question. Anybody else? Anybody else? That was an excellent question. Bella?
How do you know, like, where the 2 goes? Because I can't figure out if it goes on the top.
If you have trouble with that, just break it out and do it was 5x over 10x squared.
No, it was just 5x.
Oh, it was 5x and 10x. Just break them out. What would 5x over 10x reduce to? 2 on the bottom. 2 on the bottom, right? That's 5 over 10 is 1/2. That's 2 on the bottom. Okay? Break it out if you have trouble with that. All right, let's do another. What's the name of the game in these problems? Factor, 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 factor.
I'll remember that 20 times. Factor. Factor 20 times. I'm not going to write that.
This is as hard of a factoring problem as they're going to give you. Okay? Can I do anything with 4x squared?
No.
No. Can I do anything with x plus 8?
No.
Yeah, I could do something. Right? It's a fraction. I could put it over 1 just to make life easier so that I see that there's a top and a bottom. Okay? What about this stuff on the bottom? What can I do on the bottom? What first? When I see x cubed, it ought to be screaming that there's probably a what? A GCF. I don't know how to factor cubes. I haven't shown you how to do that. But if I can pull an x out to the front, okay, then what was left I could probably factor. Okay? So not only can I pull an x out, but 2, 10, and 48, what can I pull out?
2x.
A 2x is my greatest common factor, my GCF. Greatest common factor. Okay, GCF, GCF, GCF. What's left inside after I pull out 2x?
X squared plus 5x minus 24.
Very good. I pull out a 2x and that's what's left. Do you think this trinomial is going to factor?
Yes.
Hold on, before you do it, eyes up here. If you had to guess what factor would be inside of x squared plus 5x minus 24, what factor is there a 90% chance is going to come out of that? Why? Because then you could cancel it. So there's a pretty good chance, right? Not definite, but there's a pretty good chance that x plus 8 is one of my factors up there. I don't know. Okay, but is 8 a factor of 24?
Yes.
What would the other factor be? 3, and it would be what? X minus 3. Does that work?
Yes.
Yeah, it's almost like a cheater. Like it helps you factor it. Okay, use it. I'm not saying it always will have an x plus 8, but 90% of the time it will. Okay, so now we're factored, right? So now we can start canceling. Logan, what is 4x squared over 2x going to give us?
2 over 1.
2.
Over.
Right, that takes care of the 4 and the 2. Then what about x squared over x?
That would be x on top.
X on the top. So I took care of that, and I took care of that. I know it's confusing me writing it on the next level, but I ran out of room. I would like problems that you just continuously write horizontally. Okay, because then you can keep the top always on the top. All right, what else cancels? X plus 8 cancels with x plus 8. And where's this x minus 3 going to end up?
On the bottom.
On the bottom. And you're done. Okay? And you're done. What would the excluded value be of this problem if they, for some reason, asked you, first of all, how many would you have? 3. Right? Isn't it x cubed? You would have 3 of them. Right? And what would they be? You'd get 0. Then what else would you get?
Negative 8.
And what else?
Positive 3.
Positive 3. Why do you look here rather than here?
You look at your problem, not
You always look at the problem, not the solution, to find excluded values. I'm reviewing you because that's something we talked about the other day. Question. All right, so we did 2 on multiplication. What do we got to do now?
We got to do
We got to do divide. Okay, do you remember how to divide regular fractions? Right, 1/2 divided by 3/4.
Keep it, change
Write it down. Keep it,
Change it.
change it,
Flip it.
flip it. What do you keep?
The first one.
1/2. What do you change? The division sign changes into a what?
a multiplication.
Multiplication symbol, and then what do you do with the second one? You flip it, right? You find the reciprocal. So you put the 4 on the top and the 3 on the bottom. Keep it, change it, flip it. So now, does anything cancel?
Yes.
The 4 and the 2 cancel, you get a 2 on the top, and your answer is 2/3. 1 times 2 is 2, 1 times 3 is 3. So your answer is 2/3. Keep it, change it, flip it. So now, what are we going to do? We're going to do problems with rational expressions where you have to keep it, change it, flip it. Alright, so here we go. 8x squared plus 24x, x squared minus 5x. You should be writing this down and stop playing. X squared plus 7x plus 12 over x squared minus 7x plus 10. Here's a rational expression divided by another rational expression. Let me show you a nice, easy way to do this problem without you having to rewrite it 100 times. Okay? Let's go ahead and factor this first fraction. Keep it means that we keep this one the same, but let's go ahead and factor. If I have 2 terms, what am I thinking? Either GCF or what? What's this called? The difference of perfect squares. So is 8x squared plus 24x, is that going to be GCF or difference of perfect squares?
GCF.
What's the GCF? 8x, right? They both have an 8 in them, they both have an x in them. I take that out, and what am I left with? X plus 3. How about x squared minus 5x? There's a perfect square, but is 5x a perfect square? No, it's not. So I'm thinking what? GCF. I pull an x out, and what's left?
X minus 5.
X minus 5. Cross out what you're done with. Be nice and neat and organized. Don't use a pen. Okay? Be nice and neat. Alright, now watch. For this next step, I know that this fraction is supposed to be flipped. Okay, but what I'm going to do instead of having to rewrite it 100 times is I'm going to factor this. What does x squared plus 7x plus 12 factor into? X plus 4 and x plus 3. Right? What are your factors of 12 that add up to 7? 4 and 3. So when I factor it, x plus 3 and x plus 4. When I factor it, why am I writing it down here below? Because it's supposed to be flipped, right? The division sign is telling me to flip that. So I just factor that and I write it down below. It just saves time. Factor it on the top and write it down below. Okay? Go ahead and change this to a multiplication sign. What about x minus 7x plus 10? X squared minus 7x plus 10. What are the factors of 10 that add up to 7? 5 and 2. So I've got x minus 5 and x minus 2. Why am I writing them on the top? Because you had to flip it. So I flipped it and I factored it at the same time, saving me more time. I flipped it and I factored it at the same time. Now what do? Cancel, cancel, cancel. We could multiply, but it's easier to cancel now. 8x and x, what cancels? The x's do, and I circle that 8, meaning that 8 is still there. It needs to go in my answer. If I wanted to, down here, I could go ahead and put an 8 there, right, in my answer, because I know it's going to be there. How about x plus 3 and x plus 3? What happens to those? They cancel out. They go away. Hallelujah. Okay? What about x minus 5? What does it cancel with? X minus 5. Cancel, cancel. Be very nice and neat. Show your cancellation. Alright, last but not least, x minus 2. Does it cancel? No. I look down here. I don't have any x minus 2's, so I know I have x minus 2 in my answer, and I have x plus 4. Right there. That was in my answer, and that was in my answer. And I'm done. Okay? So what is the only wrinkle that division throws in there?
The flipping.
The flipping. That's the only way that it's even remotely different from just regular multiplication. All you have to do is remember to flip the second fraction. Okay? Are you going to get it right if you forget to flip it?
No.
No, you're not. So if I were doing a bunch of problems, I'd go through and I'd circle all the ones that were division, making sure I knew to remember to flip it. You've got to remember to flip the second fraction. Did you have a question?
No.
All right, how much time are we at?
17.
17? All right, let me put an example up there and let you guys work it out.
That was my question. 17. If we were going to do one on our next.
Yeah. 5x squared minus 10x over 4x squared minus 12, just regular old 12, divided by x minus 2 by itself. Just plain old x minus 2. So when you flip it, what's that x minus 2 going to become? 1 over x minus 2. All right, try this one now at your desk. What's the name of the game in these problems?
Factor.
Factor, factor, factor. Factor what you can. Don't force it. Don't factor something that doesn't factor. Alright, so what do you get on the top here? What's 5x squared minus 10x? 5x, and what's left?
X minus 2.
X minus 2. I take what out of the bottom?
4x.
Not 4x. See, that's what I said. Don't force it. There's no x here, So you can't pull out an x. Just plain old 4, and I get x squared minus 3. Over here, what does this become? Can't factor it. 1 over x minus 2. Why does it become 1 over? Because you had to flip it. Does anything cancel? X minus 2 and x minus 2. Anything else? No, that's it. So what do I get on the top? 5x. And what do I get on the bottom?
4 times x squared minus 3.
X squared minus 3. Is this the same as this? Are those two technically the same?
Yes.
Am I going to count them the same on the test? No, they need to be in factored form. Your answer needs to be in factored form. Write that down. This is factored form. And your answer always needs to be left in factored form. Yes, ma'am?
So the 1 and 4 would cancel out?
The 1 and the 4 don't cancel out. 4 cancels with 4. 4 cancels with 8. 1 and 4 is just 1 4. Okay, good question. All right, shut the video off.